Yeah, thank you to everyone for joining us in this section here. Today we'll be looking at the potentials of using grape pomade as a soil amendment, and we'll be looking at some soil health indications and also on soil pH, fertility, and the possibility of salt remediation as well. Today in our talk, Professor Ursula is here. She'll be helping us with the Q&A session. And then Ross Trustin is also here to help us in the same direction. In this talk, I'll give you a short overview of the program that I'm working on. And then I'll go ahead to talk about the grape pomade potential as a soil amendment. I'll try to link things as much as possible, putting the pieces together. So you bear with me as we go ahead. So my name is Isaac Mpanga, and I'm the Commercial Horticulture and Small Acreage Agent in Yavapai and Coconino County. My program area is in extension, and as the extension requires, we need some local data to be able to help the local producers as much as we can. So just a little overview of the program. So in Arizona here, we see this trend, commercial horticulture, the need for it, because when you look at the trend here, we can see a clear indication that—
Sorry, my thing doesn't work, hon.
What doesn't work?
Like trying to, oh, maybe it will. Be larger.
Let's see. Please mute yourself as you get in. Okay. So we can see that the number of farms in Arizona continue to increase.
I'm just listening.
Well, you just plug in your earbuds if you want to. I have some.
They don't work on this computer.
Hey, Linda, mute your microphone.
Okay. I tried to mute them. Okay, sorry about that. So the number of farms keep on increasing, but when we look at the farm sizes, average farm size, that is reducing. An indication that the number of the farm sizes in Arizona are getting smaller and smaller. So the need for us to pay more attention to small scale farmers as well. And when we look at the income as well, the percentage of small scale farmers by acreage is around 60%. That is less than 10 acres. And when we look at the income bracket, we can see that those making less than 25,000 are 87% of our population, the farm population. So in Yavapai and Coconino County, the commercial horticulture program is right on. And you can see in this text from Whipstone Farm, their assessment in having someone, commercial horticulture and small acreage agent, to work with them in this direction. It's something that they've been waiting for, so they're showing their excitement about it. And I've actually worked with them. I'll show a short work that I did with them so far. And mostly I reach out to the farmers using Instagram. And at this point, we have about 143 members who are on the Instagram page as well. And last year, we were able to reach about 1,600 stakeholders. And when we look at the stakeholders, the farmers who are interested, who show that the program has been useful to them, it's about 83%. And we had 16% saying that the program was somewhat useful to them. And 100% indicated that they're either using the practices, that the knowledge they gain in the participation in our programs, or they intend to use it in the future. So one of the programs that I implemented was the Beginner Farmers Colloquium, Small Scale Farmers Colloquium, sorry. So this program intends to gather small scale farmers within the two counties and also beyond, to be able to share ideas. We also invite specialists from campus and other regions to talk about specific topics based on the need assessment that we have completed. So if you are interested in joining that program, it's a monthly program, and you can see the dates in this column here. So last year, this program was able to reach about 127 participants. And based on the assessment, we can see that there has been some level of improvement in knowledge gain, and also how many growers are intending to use the gains that they have in their operations. And the upcoming program is Beginner Farmers Apprenticeship Program that I've been working on. Right now, we are recruiting. So far, we had 2 people applying. Hopefully, we'll be able to get up to between 5 or 10 to start with them and to see how the program will look like, and then we can expand it in the coming years. So in this program, we have host farmers who have agreed to host some beginner farmers on the operations. And then I'll also be giving them a monthly series as well. And then they'll come out with their projects as a final, I think, projects to do. And other projects that I've done so far is I tried to do cover crops as well, but that failed because of issues at the experimental station, no fence. So we had issues with the deer consuming everything. And this is the project that I did with Wheatstone Farm on the cover crops. We did this cover crop in the high tunnel. And currently I have 2 varietal trial going on in carrots and then radish. So the main challenge in Arizona here for production has to do with soil fertility and soil health. And when we look a little bit closer here, we can see that in Arizona, the carbon organic matter in the soil is really low. When we look at this graph here, and this picture you see on the right, I took it from the field, DK Ranch, and you can see that it's very low in organic matter. And the causes for this low organic matter is inherent factors such as climate and then soil texture, and then excessive practices such as tillages and on-site practices. An example of this is that we can see a rise in soil health practices in Arizona here. So no-till is increased of up to 103% from 2012 to 2017, and then reduced till by 71%. We have cover crops increasing up to 123%, and then manure up to 30%. And when we look closer to the county level where I'm working in Yavapai and Kukunino County, from the need assessment that we conducted, we can see that a similar trend is recorded here. And when we look, the most interesting is that the intensive till is very minimal, not so much farmers are using the intensive till. And when we look on the right, the soil amendment practices, compost is the #1 practice that is used in these 2 counties, and then followed by animal manure and then green manure. So a typical example is this, that this fire at the DK Ranch, you can see that basically manure has a good potential in helping soil fertility, but the issue has to do with limitations on accessibility at the local level. Most of the manure that is being used, farmers go a distance to Hickman to be able to get access to it. So from the need assessment, there is emphasis from the farmers that they are more interested in soil fertility and quality health management practices, followed by sustainable agricultural practices, and then we also have pest and disease management as well. So the focus has been on the first priority from the farmers that have tried to get more resources and data to support them so far. So that is leading us to poultry manure is the most used among the growers, but it's taken from far distance away. Are there any local materials that we could lay our hands on to promote so that the growers can also utilize it without having to travel so far? And when we look at when we look around, grape pomace is one of the materials that could be a potential because we have an increasing trend of vineyards in Yavapai County here specifically, which I'll talk more on a little bit later. So when we look at the Yavapai County Enology and Viticulture led by the Yavapai Community College, the picture top right is taken from their vineyards last time I visited them. And then the picture at the bottom is from Alcantara, one of the wineries, vineyards as well in the Verde Valley here. In 2018, Yavapai County employed most winery workers up to 62%, followed by coaches, which is 14%. And in 2019, more than 150 acres, which is 10% of the state land, with vineyards, were in Yavapai County. And they recorded the highest number of vineyards, which is 52 in 2019. And the most granted winery permits were also in the same county here. That is 34 out of 121 permits was in Yavapai County. Yeah, so this emphasizes the trend in grape pomace production here because there is an increasing trend in the wineries and viticulture wineries here in the Verde Valley here. So there is a need to look at how this waste product will be utilized sustainably to resolve environmental issues and to also add value to the producers. Yeah, so when we look at how the grape pomace is extracted, so this is a diagram by Kali and Co. It was published in 2018. And so when we look at here, harvesting is done from here. They do crushing around here. And when it is red grapes for red wine, it goes through this channel here. So at fermentation and then the maceration here, and then you get the grape pomace after filtering. But the white is just after crushing and then pressing. So look closer to that diagram here. You see that I use the red grape pomace from the red wine making. So that's why I'm emphasizing on this component. So we see how the process is done. So the grapes are harvested here, crushed, fermented, and then pressed. You get a grape pomace out of it. So this grape pomace that is here, we are going to look at 3 alternatives that we can put it to use in terms of soil amendment. Why we'll be looking at grape pomace at this point? Is it even necessary to look at grape pomace as a way of using it in a soil amendment or sustainably managing it? Yeah, apart from the fact that there is a growing number of vineyards in the area here, there is also a concern about environment. So worldwide production of grapes is around 70 million tons per year. And 20% of the grapes that is harvested, it's grape pomace after processing. And when we look at in America here, 12%, America produced 12% of the world wine productions. And when we look at grapes in 2017, about 7.5 million tons were produced in America. And when we look at the wine, it was, that great. And when we look at this grape pomace, so we have about one, which is a significant number that we can look at to see that in America, we have millions of tons of grape pomace that is coming out into the environment. And this was reported by the National Association of American Wineries in 2019. So when we narrowed it down to Arizona here, we can see that Arizona wine produced a trend of 64,000 gallons in 2017. But in 2007, In 2017, that trend increased up to 294,000 gallons. And when we do estimation based on Mendes et al., who estimated that 6 liters of wine production gives up to 1 kilograms of grape pomace, Arizona produced 41,000 kilograms of grape pomace, which is around 46 tons in 2007. And in 2017, sorry, the one is missing, it was up to 180 kilograms, which is 207 tons. An increase of 354% of grape pomace production within 10 years is a concern that in the next 10 years, that trend is probably going to be possibly increasing. When we look at the trend of vineyards and wineries that is growing in the area. So we see here that this is grape pomace, a picture that I took from the internet. So when you look at this grape pomace, it could be a challenge for the wineries and then for the winemakers, because managing it could be an issue. And example is from the Europe before the 1990s, most of the economic option for the wineries to manage their waste was for them to pay around 3,000 euros, which increased up to 30,000 and up to 40,000 euros, with even a potential of fine being sentenced to prison when you put it in an authorized discharge. Yeah, so to reduce the potential of getting into this kind of situation that in Europe they found themselves in this time, it's better to have alternatives that will be one step ahead of the game, so that once the increase in grape pomace is realized here in Arizona and out of state, we'll have some alternatives that the product can be used for. Yeah, which is why we want to look at regenerative soil amendment alternatives. I mean, the grape pomace is used for other things, like they extract some other product from it. Example is whiskey. They also use it in the cosmetic industry. But those ones, they are just extracting a component of it. The feed industry, the animal feed industry is also using it. The poultry and other industry within the animal sector is also using it. But the soil amendment uses the product as a whole. It doesn't leave any waste from it anymore. Yeah, so looking closer to the mineral composition, here we can see that we have the first section to be the soil that I'll be talking with, that I use for this experiment. And then the red ink is the grape pomace component. I also use zeolite as part of the amendment, and then poultry manure just as controls to see how that also works with it. Yeah, so when we look at the soil pH, we can see that grape pomace has an acidic pH, which is 3.9. And then zeolite is alkaline, and poultry manure is around the neutral 7. And when we look at the N, which is also of interest to us, we can see that comparatively, grape pomace has kind of an equivalent amount of N in the grape pomace. And when we look at PP, is quite low when we compare to poultry manure. But the interesting thing that we are also looking at here is the ammonium and sodium content. It has a 0 amount of sodium in it. And when we compare to poultry manure, it's around 7,000 milligrams per kilogram. And when we look at the sodium absorption ratio, we can see that it's 0 here, and then 13 for zeolite, and then the 9.8 that we'll also be looking at in a later slide. Yeah, so the scenarios that were set here is that, okay, we have this material that is good amount of minerals in it, how can we utilize it? The pH of the grape pomace can be increased with other organic materials such as poultry manure, because the low pH makes the composition of the grape pomace alone a difficult task because of the low microbial activity. So the first scenario was to add materials that will reduce the pH to increase the microbial activities to make the composition of the material easy. So in the first scenario, I did 100% decomposition of the grape pomace, and then 60% plus 40%, and then 60% plus 30% poultry manure, and then 10% zeolite, to see how these materials will influence the pH and then as well as the other chemical compositions. And the next scenario was that the anaerobic composition could retain more nutrient than the aerobic composition. So when you compost anaerobically, everything is sealed and nothing is possibly escaping. So the scenario is that that could be a potential to retain more nutrient than composting it anaerobically. And then the third scenario was that using the solarized grape pomace directly will be an advantage to managing soil pH and microbial communities due to the organic acids in the grape pomace. So the grape pomace, the acidity is due to organic acids in it, and the organic acids are also a good carbon source for microorganisms. So the scenario here was that when we use it directly, because of the low pH and organic acid, it will help reduce the soil pH, at the same time increase microbial activities in the soil, which will then enhance plant growth promotion. So let's go ahead and see how these scenarios came out. And I have to say that most of the experiments that all the experiments that I did were all in greenhouse experiments, and we have one field experiment ongoing that we don't have my data on it. So all the data I'm going to show you, it's greenhouse experiment. Yeah, so for the first scenario, let's look at the pH. The pH here, we can see that this here is only the grape pomace, and then this grape pomace plus poultry manure, and then grape pomace, poultry manure, and then zeolite. And here, what we can see is that the grape pomace alone, it took up to about 8 weeks before you can see an increase in pH. But when we look at the grape pomace plus poultry manure, even at week 4, we can already see that the pH increased beyond the initial pH here, reduced a little bit on week 6 and then continually increased. But when we look with zeolite, zeolite was more stable in terms of the pH increase. So in terms of composting, this is how, let's look at the next physical characteristics. So this is how the compost looked like in day 0, and the termination was at week 15. So we can see even the physical appearance of the compost to see how it is. You can see that with the grape pomace without any poultry manure, the color still looks the same, just a little bit dry, and it doesn't show any much composition. But when we look at the grape pomace plus poultry manure and with zeolite, we can see a good indication of decomposition. So this is a closer look at the characteristics, both under aerobic and anaerobic conditions. So the first row here is the grape pomace and aerobic, grape pomace plus poultry manure, and then grape pomace plus poultry manure, and then zeolite. And then the second row here is under anaerobic conditions. And when we look at the physical characteristics, this is very much interesting. We can see that the color still remains almost similar to how it was before we started the trial. And let's look at the CN ratios. The CN ratios is an indication of the decomposition and how the minerals could be available to the plant. So we can see that it's still a lot of organic matter that is not decomposed, both under the aerobic and anaerobic conditions with only grape pomace. But when we look at the grape pomace plus poultry manure and then plus zeolite, we can see that there has been a good indication of decomposition and possible availability of mineral materials. which we'll look later on here. So this is under aerobic conditions. When we look at the NPK, calcium, magnesium, sodium, and then sulfur of the compost material that we did. So we can see that there is a significant amount of N, and that when we add poultry manure and zeolite, both for NPK, both for N and P, but for K, we don't see any difference here. And then for calcium, we see a difference, magnesium, we see a difference, and then sodium, and then sulfur as well. So what is the best option to compost the grape pomace? Is it aerobic or anaerobic? So let's look at the comparison between the aerobic and anaerobic. Let me give a little explanation here. Here I did only under the aerobic conditions because the anaerobic, I did not open it until the end of the experiment. So I tried to avoid air getting into the material. So that's why I left it unopened and could not take data on this until this point here. So at the end of the experiment, this is how the material looked like in terms of the mineral composition. We see that the grape pomace here, this is the composition, the mineral composition of a grape pomace without composting. And when we look at the grape pomace alone, comparing the aerobic and anaerobic, we'll see, we don't see so much differences in terms of the mineral composition, right? Yeah, here we see a little bit up in terms of aerobic for the N, but here too we see a little bit, but it's not something that is significant different. Yeah, so in summary, the aerobic and anaerobic comparisons don't seem to have much differences in terms of their nutrient, except for K, where we saw a higher K in terms under the aerobic decomposition compared to the anaerobic. Yeah, so when we talk about compost, it mostly has to do with, is it well composted? Are there any potential pathogens that could be an issue for this material? So we look at the total coliform, and then we also look at the microbial activity in terms of bacterial, here the APC, and then the fungus under the two conditions. When we look at the bacteria, we can see that we have more bacterials under the aerobic compared to anaerobic. And then what is also interesting is that when we look at the plus and without poultry manure under the aerobic composting, poultry manure kind of decreased a little bit of the bacterial component, which is surprising. And then when we look at the under anaerobic, poultry manure increases the bacterial composition here. And when we go ahead to look at the total coliform, which may be an indication of pathogen in this material, we can see that there is basically a good potential here that there may be pathogens in this regard, but with poultry manure without, and then under anaerobic conditions, we don't see that much potential. Here, this could be as a result of the material being covered and not having any much potential to environmental exposure. But in this case here, I'm not sure why here it's more and then not here. And a similar trend was also for the fungus communities. Yeah, so there is an ongoing incubation trial to compare these three materials to see which one will be the best. And a field trial with whipstone, no, not whipstone, blooming rate to be able to see how these compost materials are in the field in comparing to some commercially available compost and then also other materials as well. Yeah, so the next question is that, what about sterilizing and using the grape pomace directly without composting it? Because we can see from the chemical compositions that the grape pomace has good amount of N and other nutrients in it, and it's also very acidic. So when we use it in our field, which is mostly alkaline, is there any potential that we could affect the soil acidity and increase nutrient availability for this for plants uptake. Yeah, so this was set up in this way. So we have no fertilization here, and then we have 5% grape pomace, and we have 3% grape pomace plus 2% poultry manure, and then 3% grape pomace plus 2% zeolite. And when we look at both the maize that was grown for 30 days and then the wheat for 40 days, we can see a good trend of the grape pomace alone increasing maize growth here. And then we can also see significantly when we compare to the no fertilization without any material being added. And a similar trend was observed for the wheat as well, except under the zeolite, where we do not have any significant difference when compared to no fertilization. So at this point, we know that the plant is able to take up the nutrients in the grape pomace directly. So we want to see the shoot mineral composition, how it look like. So the first section is the shoot mineral composition for the maize. And when we look at no fertilization compared to only the zeolite, we can already see that it significantly increased both NPK and also the micronutrient concentrations in the shoot. And a similar trend was observed under the wheat as well. And when we look at plus the poultry manure, it's also similar. It's also increased compared to the significantly increased the mineral shoot compared to the no fertilization as well. The interesting thing is that when we look at calcium, magnesium, and sodium, there was a reduction in the concentrations here when we compare to the no fertilization, but with the poultry manure or zeolite, it went up a little bit again. And a similar trend was also observed under the winter wheat as well. So what are the possible mechanisms of this solized grape pomace on the maize and the wheat growth on shoot mineral concentrations? So now I want to understand why the plant was able to probably take out the nutrients and make significant differences when we compare to no fertilization. So I did this experiment to see how it affects the soil pH. When we look at the soil pH in this here I use the red bar here is only the soil without any amendment. And the second bar is 5% grape pomace. And the next bar is 10%, 20%, and then 40%. And a similar trend is repeated for the zeolite and then poultry manure as well. The interesting thing is that when we look at the grape pomace trend, we can see that as much as we increase the grape pomace amendment, there is a decreasing of the soil pH in this regard. And this means that when we look at the graph on the right side, the soil pH within 6 and 6.5 is where most of the nutrients are mostly available for plants. So if we're able to reduce the soil pH from around this range to this range here, then we have the potential of making more nutrients available for the plants to take up. And the reduction in the acidification is due to the organic acid. This authors here reported that organic acids are a major component of the grape pomace, which we can associate to the effect on the soil pH reduction. Yeah, so we look at the microbial community as well. Do they have any effect on the microbial community? And when we add the solized grape pomace to the soil. Yeah, so here we look at only the winter wheat rhizosphere soil, sampled it, took it out for analysis. And the red here is the diversity index, indicating the diversity of microbial organisms in the soil. And when we look at it, though it was not significant, there was about 30% increase when we compared to the soil without the solized grape pomace. And in terms of significant difference, we can see that there was a significant difference for the saprophytic microorganisms, and then also for the total fungus. The saprophytic microorganisms are fungus that feed on dead materials, so it makes sense that you see more of them here in the treatment that we added the Zeolite grape pomace than we have in the soil without any amendment. So we also look at the microbial biomass. When we look at the microbial biomass, all the microbial biomass seem to be significantly affected when we added grape pomace. And when we look at the percentage change here, we can see that it's a high biomass that was, microbial biomass that was observed in terms of the Zeolite grape pomace addition. Yeah, so we can say that the material has a potential of inducing microbial activities as well, and also a labor pool of organic matter, which can be explained with this gram positive, gram negative ratio. The more you have, the higher the ratio, it's an indication that there is a recalcitrant form of organic material in the soil that the microorganisms depends on. And the low ratio indicates that there is a more labor pool of organic sources that microorganisms will wholly depend on. So we can see a more balanced community in terms of the gram negative and gram positive compared to the no fertilization variant. So when we look at the relationship to see which factors really influence the nutrient availability and uptake in the two plants in the winter wheat specifically, we can see that there is a good correlation between the soil pH and then the microbial biomass than the microbial diversity. So we see that the microbial, the pH has up to 95% correlation with N, and then 97% with P, and 97% with K. And then the microbial biomass with PLFA, which is phospholipid fatty acid analysis, indicates a 90% correlation with N, 95% correlation with P, and then 93% correlation with K. When we look at microbial diversity, it's very low, 27% in N, 32% with P, and then 43% with K. So we can say that the pH and then the microbial biomass had a more correlation in terms of the nutrient availability and uptake by the plant than the microbial diversity at this point. Yeah, so another thing that I look close at is that when we look at these two pictures here, we can see that there is here kind of like water slowing down, how the water moved into the soil when we compare the variant with the Zeolite grape pomace and then just the soil. You see the soil is still, the water is still here, just within some seconds of pouring it. You can still see the water moving slowly, but here within a few seconds, you don't see the water again, everything moves down. When we look at the soil structure as well, so this, you can see the soil structure is a little bit changing here in terms of this here, and it seems to have this binding effect that holds the particles together as well. All this is for the investigation. So I was talking about the sodium uptake. So when we look at the sodium uptake in the maize and then the wheat, we'll see here that there is a decreasing trend in the concentrations of sodium in both cases. And this we can, there's a question mark as to whether the grape pomace is reducing the soil salt content and making it more unavailable for plants, or it's just a dilution effect. So at this point, we cannot specifically emphasize that it's a specific issue. I just wanted to point it out. There is a trend here in terms of the sodium uptake. And when we look on the left here, we can see that the grape pomace has like sodium absorption ratio of 0, which is a good indication of less salt in that material. Yeah, so in summary, we can say that the use of grape pomace as a soil amendment seems to have a great potential in alkaline soil pH and health and fertility management. The compost, the grape pomace also with manure addition is beneficial for improving the compost mineral composition. But the aerobic and anaerobic composting of the grape pomace seem not to have much difference in terms of the mineral composition. And the use of the solubilized grape pomace seem to have a more potential, in terms of the when you consider how much time that will be used in preparing it, and also comparing it to the compost. And then the other section is that the solubilized grape pomace could be an alternative for desert alkaline soil management and fertility management for small-scale farmers. If the material is more abundant, large-scale farmers can also benefit from it. So using the grape pomace as a soil amendment could also be a good way to manage the waste from the growing wineries and industries in Arizona and beyond. And then the research on this use of grape pomace, especially solubilized grape pomace, needs a field-scale trial for us to better understand how to use it and how it affects the soil. Yeah, so at this point, yeah, I'll thank the Verde Valley Senior Center. They give out their greenhouse for these trials to happen, and then also Brunel, where the field trial is going on. So I'll pause here and then we'll see if there are some discussions that we can talk about. Thank you all for your attention.
So Isaac, there's one question here, and that question was, what traditionally happens to the byproduct, to the grape pomace? Does it go into the landfill, or could it also be used as feed for livestock?
Yeah, so basically, some of the wineries try to compost it. Others, they just throw it in the landfill. Most of them just throw it in the landfill because it takes so much time to decompose, and they don't seem to have any technical idea on how to manage it so they can get it decomposed earlier. And the other thing is that some of them complain that it introduced flies and bugs into the fields, and because of their operations and their tourism oriented kind of operations, they don't want these bugs and flies to be flying around when the visitors come around and things like that. So those are some of the challenges that they face using it, which was why I tried to work with the solubilized grape pomace to see how that could be effective as well. So instead of composting it, that may draw flies and things, you just dry it. We have a good sun here. You just put it in the open sun, it will dry quick. Grind it or pallet it and you can use it. But we need to have field scale trials on this to optimize it. Yeah.
So another question was about zeolite. Why is it used and what does it do?
Yeah, so the reason why I use the zeolite is that, so zeolite is an alkaline, kind of like, it's a material that is very porous in nature. They use it in the water treatment a lot. Yeah, so it's porous in nature, has a very high cation exchange capacity to hold nutrients and water like that, and also has a very high pH, which was why I use it in this case. Yeah, so zeolite, it has a potential, or if you want to reduce, there are reports that if you want to reduce like cation losses, like ammonium, potassium losses in your soil, you could use it. With it, it holds these nutrients together and bind them, hold them from leaching. Yeah, so which is a good material. There is a publication on it, actually. I did a publication on it that I can share with you on that to get more insight on how it's used for soil amendment as well.
Okay, great. Another question was about, is the grape pomace available to the public and to home gardeners? And if yes, where can people pick it up?
Yeah, so that's a good question. Yeah, so in terms of the availability, as I indicated in the earlier slides, we have, yeah, you can basically get it from the wineries, and it's available around August, September, thereabout, when the grapes are harvested and crushed for the wine productions. So those are the periods that you can basically get the material from the winery. So if you contact the wineries around your locality closely, you can get some of those materials if they are not using it. You can just pick it from their facilities when they crush it and distill and filter the juice. You can get the material from them. But in terms of quantity, I don't think there is so much quantity availability that large-scale growers can use it, but the homeowners and then the small-scale growers can get this material and utilize it. Yeah.
Okay, so are there any studies that have been done yet on grape pomace in vineyards and its effect on plant and berry growth?
The compost, yes, I know there are some, yeah, in New York and California, they did some work on using the composting, trying to compost it and use it in the vineyards. But the solidized form, I'm not aware of any studies that has done this. And the one concern that the grape someone raises that because it also has good amount of potassium in it, it could be an issue for them in terms of the quality of their wine and things like that. Yeah, so all these things needs to be investigated and see if that is actually true or not, because the poultry manure that they use is also having good amount of potassium in it. Yeah, so that shouldn't be, I don't think that should be a concern to reduce the usage, but rather we should investigate, try to get some grants to investigate to see how it actually affected real time, and then we can make recommendations in this direction. Yeah, but as of now, this is what I can say about it. Yeah, before we go on, maybe I should there is a poll. I should line the poll whilst we do the discussion. Yeah, so I'll just line the poll. Feel free to contribute to the poll to help us in our future programs. Yeah, so let's go on with the questions while we discuss.
Okay, so also there is now the link in the chat on the publication on Zeolite that Isaac just mentioned. So here's the poll now. So please respond to that.
Yeah, if you can unmute yourself and ask the questions direct also, you are welcome to do so. We have some few minutes to go. Yeah, so if you have some question, you can unmute yourself as well and then ask it direct instead of putting it in the chat. Yeah.
I have a question.
Okay, let's hear you.
Isaac, you met me over at Oak Creek Vineyards to look at the compost, and have recently been using sheep manure in addition as an amendment for Tempranillo block. And I'd like to know if it would make a significant difference if I added the grape pomace directly to the compost as opposed to just directly to the grapevines and then aerating the soil from there.
Yeah, so yeah, composting it is highly recommended. Yes, and adding the sheep manure is great. It will, like you've seen in the poultry manure, increasing the pH and helping the decomposition facilitate quite well. That is a great way to compost it. But if you're intending to look at, if you have like an alkaline soil where you want to utilize it and to potentially reduce the soil pH, then putting it direct will also be very good. But one thing you have to know is that putting the grape pomace direct without grinding it or pelleting it may have a potential of the seeds germinating sometime, because the grape seeds could potentially germinate sometime along the line if they are not grinded or pelleted, crushed. You understand? But composting potentially could kill Even composting, after composting, if the material is not well composted, the seeds could still be germinating, so that is something that you have to look at to see how you can best use it and not have issues with the grape seeds germinating in the field. Does that make sense to you?
Yes, that answered my question. Thank you so much.
All right, welcome. Do we have any other questions?
Yes. Also, there are still a number of people who haven't voted on the poll, so if you can please do that now. Another question was about a site that has low nitrogen, high phosphorus, and high pH. And would grape pomace be a good treatment for that?
He said low nitrogen, high phosphorus, and then high pH.
And low nitrogen.
Okay, yeah, so that would be a good fit actually, because here in the table that I showed first, we can see that the grape pomace has a high amount of nitrogen and low amount of phosphorus, and then low pH, right? Yeah, so if your soil is low in nitrogen, high in phosphorus, and then pH, that could be a good alternative to use. But bear in mind that, like I said in the earlier submission, using it direct may not be helpful because of the seed. So if you can solarize it, if you can dry it and then pellet it or grind it somehow and use it, that will make a good difference. So don't try to use it direct. You may use it, but that may be at risk of future germination of the grape seeds in your field that you have to deal with as weed.
Okay, so another question is the acidity in the pomace from the leftover grape skins and seed alone, or somehow introduced in the fermentation process?
Yeah, that's a very good question. So it's both actually. So the grapes has a lot of organic acids, and then the fermentation also introduces like lactic acids in there. So both contributes to the acidity. It's not just the fermentation, and it's also not just the original organic acids in the grapes. Yeah, so both actually contributes to the acidity. That was a great question.
Good. So here's an announcement from Kirsten Ball. Growers would be happy to release the byproducts to growers and gardeners, but there's resistance in transporting the products away from the vineyards to other places than a landfill, especially during harvest, because that's obviously when they're busy. So there needs to be then, I guess, a mechanism to facilitate that distribution. Here's another comment. I used uncomposted, not ground pomace for a small experiment before, and I grew a small grape forest. I'm glad Dr. Mpanga mentioned this.
Yeah, you definitely will have that challenge if you don't grind it and pellet it to make sure the seeds are crushed. And one thing we have to also know is that when you grind it or pellet it, you also accelerate the organic matter decomposition, and then also make more of the minerals and the components in the material more available to be utilized by the soil microbiome and then by your plants as well. So grinding or pelleting it is really something that you should not avoid if you want to use it direct in your field without composting it.
Okay, so I'm going to ask the next question and then I will sign off and Russ Tronstedt will take over. So what is the cost per ton to process useful pomace with manure and zeolite?
Cost per ton? Oh, that's a good question. Yeah, so how should I respond to this? Because I do not do any, that would be something very interesting to do. Actually, we submitted a grant on this, and we asked Ross to help us in that component. So that would be a good start to get the cost benefit analysis, so we can have the cost, how much it will be. And also because these experiments that I did were at a smaller scale, yeah, just supposing it like to a larger scale to do the cost benefit analysis may not be accurate. So at this point, getting the costs out at this point with this small scale experiment may not be the best option. So if you're able to get some grants and do some field work, that would be the best way to get the cost benefit analysis. So we see how much it will cost to produce this, either sterilized or composting, and then we can see the best alternatives in terms of yield comparison as well. Yeah, so that was a good question, but at this point, I will not be able to give any figure out there on the cost for producing that.
Yes.
Also, are you satisfied with that? She's left. Okay.
So let's remind everybody to there's a couple that still haven't completed the poll, if they could do that. And there's another question here that's really interesting too, Isaac, with regards to, what kind of equipment can be used to grind like large quantities of pomace, to where if you have, a lot to go through economically, to where you can grind it in large quantities to,
Yeah, so there are a lot of palleting machines out there that you can buy to either pallet the material as granules or in like rods form. But I will recommend palleting machines that will pallet into the granules, because it will make the spreading easy than the rods. Yeah, so those machines could be the best option to use. What I used here was I just use, because it's small scale, I just use a kitchen mixer to grind the dry material. Yeah, so at the large scale, with the grant that we submitted, hopefully we're able to get it, and then we can buy a palleting machine that will pallet it, grind and pallet. So that will be the only alternatives that I will have available. Yeah. But as to the specific machine to buy, it will depend on how much you want to use it for. If you want to use it for commercial purpose, then you have to have like a good capacity that can do a high volume palleting. They also have smaller ones that will cost maybe around $3,000, $4,000 to be able to have at a small scale. If you want to do it for a small scale, you can get a palleting machine around that cost as well.
Okay, so it looks like everybody's completed the poll. Thank you for doing that. If there are any other questions, if you want to just unmute yourself and ask those, that would be fine as well too.
That's right. Yeah, we have 1 minute. So if you have any other question, you can ask before that. Okay, maybe I should share the poll results for everyone to see what it looks like with a poll. Yeah, so from the location, we have 11% from Coconino, Yavapai County, 47%, which is great, and other counties, 42%, also great. And then on the rate of knowledge gained, yeah, 47% steady gain, some 76 to 100%, 50%, up to 75% was 26%. Yeah, so yeah, 42% said they wouldn't use it, and then 58% said they will use it, yeah, which is understandable. And then in terms of the content, yeah, good, excellent. All right, so that's all about it. I'll stop sharing this poll now. So thank you to everybody, Ross, and then the Osler for helping us in this direction, and everyone who participated. We're going to try to get it into an audio form for other people who couldn't join us. We had about 80 people registered, but basically we had maybe around 45% who were able to attend. So we'll be able to share the recording with everyone as well. And thanks to everyone for joining us today. Don't
Yeah,
forget to sign up for other programs as well.
and you'll put the, you'll put the link of the recording up on the where you have the initial announcement, right? On the extension.arizona.edu events
That's right.
programs.
That's right.
Yeah, so that's up higher in the chat if you haven't seen that.
Okay.